All right. As always, I love doing the topics and I love talking about all kinds of different things that we can look at. But this was one that has sort of taken a life of its own here lately. And I'm going to explain why before I get started. A good example of this is if you look at, we were talking about EVSE. Now,
Yeah.
when you go look at that, if that is hardwired and the manufacturer says on the load side they've already provided GFCI protection, you don't need GFCI protection. Now, if it was cord and plug connected, yes, you would because that's an
Yeah.
outlet. But this is my thought process on it, and they look at it the same way we do. Apparently, is what I think is they realize that is not an outlet; it's cord and plug connected. Therefore, they needed to have some type of means of GFCI protection for the user when he was cord or using the cord to plug it into that car, that electric car.
Yeah.
So
Human interaction.
that's right. And you'll remember this. I've always stated that if you had GFCI protection, it had to deal with user interaction. That was the first thing I remember you had me on the Willie Jackerson podcast and we're asking all
Oh
these
yeah.
GFCI questions, and I was
Yeah.
explaining all this. Well, now they're trying to say certain people because it's going to run their argument. They go, no, you've got to put GFCI protection on. So, in other words, they're saying you got to have two forms of GFCI protection. Now, they specifically have also stated that it doesn't matter what the listing and labeling of the equipment says. I still need that GFCI protection. NEC overrides it. And I'm going to tell you right now, that's a bunch of crap. That's not
Yeah.
true. If
I
the
agree.
listing and labeling is on that equipment, it has gone, what's it say?
Oh, nice. I like that. Yeah. Next week's myth is what section of the code are unenforceable. We're gonna go informational notes, maybe.
I tell you what, I got a lot of things I can tie in to explain it. And this
Nice.
presentation is going to be a good example of that. But I've, if a manufacturer comes in and tells you not to put GFCI protection on it, not do this, not do that, that equipment is listed and labeled, and it's already been tested to know that it does not need that. So
Right.
there is UL standards. So basically, what some of these people out there saying is that the NEC overrides the listing and labeling of the equipment, and it doesn't. And matter of fact, and that's why I'm going to start this off with custom made equipment. If I have somebody come out there as a third party certification, they're using UL standards to put a field installed label on there for that listing and labeling, and they say no GFCI protection on that, guess what? That's the way it is. And the
Yep.
and the authority having jurisdiction, guess what? They're going to accept that because they had somebody come out and approve that.
Yep.
So for somebody
Agree.
that is pushing an agenda, in my opinion, and they come out and say, no, 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 you got to put GFCI protection upstream. No, you don't. And I'm just going to
Yep.
say that right now, but I'm going to prove all this tonight. Okay.
Well, and you know that we fought this like really hard with the CAM process and the NITMAMs and everything, and it was just this big arrogance of you need to do this or you can't install that in that location, and I was kind of actually shocked that they did that. That I'm saying I was saying certain members of
We know
co-making
who it
panel.
is.
But like you have certain members of the code-making panel voted to try to force this on everybody. I call them the code commies, but they tried to force this, and now what's going to happen is we're going to have an across-the-board exception for everything incompatible, regardless of location, in 2026.
Mhm.
That's coming.
Now, this is the most important part is the very first sentence in this. And what does it say? It says Underwriter Laboratories and other such laboratories are nonprofit organizations supported by the manufacturers who submit merchandise. Now, listen to this that is for the testing of merchandise. Listen to this for safety
Right.
when being used. So what I'm trying to say is somebody comes in and says, "Oh, I need GFCI protection upstream," but here's the manufacturer with UL coming out. They're doing testing on this. They trying to tell me that UL hadn't done the testing on that equipment for safety.
Yeah.
I mean,
And Andrew makes a good point. This is exactly what me and James said. I couldn't imagine putting a Class A device on there when the manufacturer says a Class A device is not compatible with that equipment. So that's why they included a 20 milliamp EBSE, at the unit for personnel protection. And then all of a sudden you're like, oh, well, these code commies told me I got to put another one upstream. It trips. Now you're stuck at home and can't go to work because you listen to the code commies.
Sure. And then listen to this. It says the UL or any other approved testing laboratory label assures the user that the manufacturer of the item, now listen to this, has submitted samples of the item to the laboratory for testing, and they were found to meet what? The minimum required safety standards. So they're telling you when they design this equipment, it is to meet safety. But yet you got somebody coming in saying, "Oh, that doesn't provide safety." That is ridiculous. It just amazes me. But I'll tell you another.
And especially how they mention that if you cord and plug connect it, you have to comply with Code Making Panel 2. If you hardwire it, you comply with Code Making Panel 12.
Sure.
And that supplements or modifies Chapter 2.
Yeah. I agree. Now, I want to go down. I'm going to skip the next paragraph because it just gets into the manufacturing process. But there's a for example that ties that in. And it tells you if the product passes, now this is important, the exhaustive test of UL in accordance with established standards, it is added to the official UL published list, and the product is then known as what? Listed by Underwriters Laboratories.
Yep.
Now, that just amazes me. And then, of course, the UL label can be molded or stamped into the merchandise, however they want to do it. And then I put a note right after this. The same procedure is used by other testing laboratories. That's, guess who it's approved by? OSHA.
Yep.
Now,
and one big thing I want to throw out a huge disclaimer on this. A lot of people, we might actually do this as a myth. And this could even be one we throw in there. Everyone thinks that every electrical part has to be UL listed. That's not true.
That's not true.
They can be listed by different agencies, but they're listed under the same standard.
That's right.
So it's a UL standard, not necessarily. So that gets confused a lot. That's another myth that we might have to bring up, but I just wanted to throw that out there.
Yeah, we can do that. Now, this is important. This next part, the very last paragraph here. An item approved by testing laboratories, however, is not necessarily approved for all uses. Rather, a testing label means that the item or device as labeled, now listen to this, is safe only for the purpose which it is intended. And in other words, you can't come in and modify that anyway. So if you have like an EVSE out there and the manufacturer says, we've got this GFCI protection on the secondary side, and that is safe for the purpose of which it's intended, you don't need another GFCI device upstream. You see what I'm saying?
I agree.
This is exactly some of the things we've been talking about. And all you have to do is just go research UL, OSHA, third-party certification, the UL White Book, or you just go to our design book and we tell you everything that you need to look at.
I'm smelling a little Justin Gibbs on this one.
Can you restrict the use of an outlet or receptacle? Leads us back to when replacing a receptacle. I'm not sure exactly what he's asking there. The receptacle is a device. The box is the outlet. So if you're looking at the receptacle and saying you need GFCI, I'm assuming that you're getting in if you went out there and had a device that's out there and there was no equipment ground out there. Is that what you're asking?
So I think 250, 114, I think we talked about this before. I think it's when you are able to not use an equipment ground. Like I believe 250, 114 is when you use like a GFCI instead, like in lieu of. So basically, you just have a hot and a neutral, and then you just have an ungrounded conductor and a grounded conductor, and then you use a GFCI in
Well,
lieu of having a 3-wire connection. That's a really valid argument, Justin. It's just
well, that's
um,
allowed by code. I mean, when you're getting into replacement of receptacles and stuff, and you're providing GFCI protection because it's required out in that location.
yeah. So um,
In a
he's
foyer,
saying that if you locate it in the foyer, GFCI is not required.
why would you put
Um,
it in the foyer?
yeah, I mean,
I mean, I'd put it out in the garage. I don't know why you'd put it in the foyer.
yeah, and he's driving. It'd be awesome to have a debate with you, Justin. It was really awesome to have you when James didn't even show up, and I just had like a spirited debate between Justin and David Englehart, and I was just managing it, but it was pretty funny. Andrew, I also have a problem with the UL listing these low profile lights trying to jam 12.3 and EM remote balance the spot size of my thumb. Yeah, I could agree with that.
Yeah.
You wonder did they test it? You know. Oh, so I see what Justin's saying. He's basically saying inside the door of the foyer. So it's technically a damp location or technically not outdoor, even though it is outdoor, I guess. But I don't know. I think trying to play word Scrabble with where people I believe are misinterpreting the outdoor outlet thing. That's the way I take it. I just think just because there's an outlet there doesn't mean that you could call it an outdoor outlet. You could say basically they're trying to justify something I feel was a mistake, in my opinion. But
Well, first of all, I don't know why you would put it on right inside the door there in the foyer. I don't know why you would do that. I guess it's saying.
well,
I mean, I guess if you had a round driveway,
he's
come up
saying
in
like
front of the house.
outside garage, but then that would be what they say is covered under 210.8F for 2023 expanded areas. To me, it's just such a stretch. I mean, like I joked around about this a lot. I was like, "Hey, I'm gonna put an AC unit within 6 foot of my sink. Is it all right?" Yeah, sure it is. There's nothing in the code that says you can't hardwire an AC unit within 6 foot of your sink. But then you can, you have to have Class A protection when it's outside next to your house. It's bonkers. I just don't get it.
I would think if you were going to do something where there's a receptacle right inside the foyer, I'd just say get you a GFCI device and put it on there because I think that's where you're interacting with it outside, and you would need
True.
GFCI protection. I wouldn't even
I
argue. I'd say it doesn't matter if it's considered a dry, a damp, wetter location. You're still interacting with the cord and plugging in from outside. It's just like
I
if
agree.
I had a hardwired unit, and they provided on that secondary side of that unit.
Yeah.
It's where the human interaction comes in outside. When you actually look at receptacles that are outside, why do you got GFCI protection for all those receptacles? Because you got human interaction plugging
I
in and
agree.
out in a damp location out there or a wet location.
Yeah. And me and you talked about this kind of at length, James. And it was just basically like all the different can of worms that this opens when you say, oh, well, basically we said all outdoor outlets because we wanted it to apply to everything. And we're like, okay.
No.
Well, how much research did you do on everything? Because you wanted it to apply to HVAC units, but you didn't even do research on HVAC units.
Well, I can tell you based on that, just based on what the Standards Council did at NFPA, they basically slapped the hand of Code Making Panel 2 for what they did. But Code Making Panel 2 came in and they come back after the fact because they started saying, oh, we want it for AC units. They didn't put that in any of their substantiation. Everybody, at least in my thought, because we even did it in our publication, that we thought they were talking about receptacle outlets outside, and our illustration specifically reflected that. And then they had to put an exception in there. Well, then they got a task group together for the 2023, and the task group come in and specifically did all kinds of different AC units and said there's no way that we can even get our equipment to do that first and foremost. But we're not, there's other equipment that we're going to have problems with too. And the Code Making Panel 2 rejected the TIA of the task group that did all this research and work. They actually did work on this. It just wasn't their opinion. And they rejected it, wrote their own TIA, basically wanting it for everything, and then, but provided no technical substantiation at all. And I can tell you, I've been doing this a long time. And before they ever accept something or do something of that magnitude, you usually provide some type of technical substantiation. Well, the technical substantiation that Code Making Panel 2 provided was a kid that got killed, but it wasn't due to the listing and labeling and how the AC unit operated. It had everything to do with it not being wired properly. And that's what caused the hazard. And they just completely dismissed that hazard. Well, when you look at what the task group done, they showed there basically wasn't no hazard. So the Standards Council come in and basically said the same thing that we had been saying, and they slapped Code Making Panel 2 on the hand and said, your TIA that was submitted provided no technical substantiation at all, but yet what the task group did provide all the technical substantiation we needed. So they basically got rid of the TIA from Code Making Panel 2 and accepted the one from the task group. That told me everything I needed to know right there, that there's an agenda right there. And I'll say, I don't care if it upsets Code Making Panel 2. Something is fishy right there.
Yeah, it's just the optics of it. It's kind of bizarre. I mean, I know that Nihad El Sharif had good intentions with passing the public input, getting the public input passed by one vote. But I just don't think that Nihad's going to get it to apply to everything installed outdoor with dwelling unit. I wanted to reply to Justin. So what this is all about, Justin, just to catch you up, we did a thing on EBSE. Manufacturer instructions said if hardwired GFCI Class A GFCI protection is not required because the unit has personnel protection. It doesn't say what class it is. So this is where the argument comes in, because they're saying, the Code Making Panel is saying that it's GFPE, it's at 20 milliamp because it's compatible with the equipment. And the charger is actually in the car. But then the other part of this too, Justin, is it says when cord and plug connected in a GFCI zone, then you need to provide Class A protection. So we're not saying that the EBSE doesn't require GFCI protection. What we're saying is that the manufacturer listed and labeled instruction says it's hardwired, does not tell you what location. It could be outdoor, could be in a garage, could be anywhere. If it's hardwired, it says does not require Class A protection because it's integral to the equipment.
That's right.
And that's what we're saying. We're not saying that it doesn't need it, So
And that takes me right back to the first sentence when they talk about third party certification, that they tell you that when they do this testing for that merchandise, it's for what? Safety. So that equipment has been tested for safety in order to protect people within that are using that EVSE equipment.
yeah, and I agree with you, Justin. That's exactly what we are saying.
Exactly. Okay. All right. Now we got that. Let me move on just a little bit here. Now
Okay.
I did put a certification tip in here, and I'm just telling you that these are things that we put in here that we want people to pay attention to. So once equipment has been approved, it is not to be modified in any way. Okay. It must be used as instructed by who? The manufacturer. And that ties into what you just said. If the manufacturer says if it's hardwired, no GFCI protection, it has gone through the rigorous UL testing and labeling in order to get that certification for its listing and labeling. Then it tells you, we did as an example here, the wiring or any other elements are not to be changed out or rearranged in any manner that does not comply with the listing and labeling of the nameplate on that equipment, or listen to this, or accompanying what? Literature.
Right.
Now, I will tell you, that type of wording has been in our books for over, 20 years now, since we started putting in the UL and OSHA and tying all this in. And nobody has ever complained with this. But now, all of a sudden, because some people want GFCI protection on everything, they're just discounting what UL does.
Yeah.
That's the way I look at it. But hey, I'm just
Yeah.
showing you what it says.
Yeah, I agree.
Now,
No, this is really good information. I know you dug it out of the vault over there, the
well,
old Stall Cup Labs.
we've got, God, let's see, 1, 2, 3, 4, 5, 6, 7, 8 with 1, 2, 3, 4. We got 8 double, or just say 8 bookshelves, 5 rows each, that are complete full of just electrical information. And then I've got over here setting 4 file cabinets that are 4 drawers each that are full of nothing but UL standards.
Nice.
So when I go in and I have to start looking at stuff, you can bet I have access to a lot of good information.
Yes,
you know,
sir. I appreciate you bringing it.
you know what it reminds me of, like when we were doing the voltage drop, and I was showing the testing that they did. This was back in the American Standards Handbook, I think, and I was showing different sizes. And based on the size conductor you're using, when they told you to start using voltage drop calculations. And that was amazing because, like, number 14 was like when you got to what, like 60, 70 foot, something like that.
Yeah.
I mean, you just have to sort of look at all that stuff and how they used to do it.
Dude, only hacks use 14 gauge, right?
Yeah.
No, I'm just kidding.
Okay. Now, the next part you're going to look at is the UL White Book, and everybody knows about this and that deals with stuff in the electrical industry. This is your general information, electrical construction. It goes through all this. But what it does, it provides a service for the classifications of products. Now, listen to this, that have been determined to meet appropriate requirements of the applicable international publications. For those products that comply with the requirements of the international publications, the classification marking may appear in various forms as authorized by UL. Okay.
Right.
So, in other words, what this means is you go in and say, I was looking at AC units. And if you look up there, it tells you electrical heating and air conditioning equipment directory. And in other words, what they're saying is they've already tested that equipment, and that equipment is safe to do the intended function of what it was intended for. So,
Yeah. So
why all of a
just
sudden do I need GFCI protection if I've got equipment here that's already UL approved and we hadn't had any accidents or anything? The only accident that they want to bring up is something where it was wired incorrectly. It had nothing to do with the unit being a bad unit. It met its listing and labeling requirements. So therefore, to me, that AC unit was what? It was listed and labeled properly.
Yeah, and just for all the listeners out there, the UL White Book is now actually what they call Product IQ. So you could just go on Product IQ, look up, type in what you're looking for, and it'll come up. And that is basically the UL White Book. It's not the UL White Book anymore. It's basically called Product IQ. So you can look
Right.
up Product IQ, and that's the new UL lookup for your products.
Okay. Now, this is where you get into approval. Now, watch this. OSHA requires. Now, I'm sticking with OSHA because OSHA is the National Electrical Code does not recognize where you deal with third party and all that. All it talks about is listed and labeled. But OSHA does recognize the listing and labeling and then getting into third party certifications and using the UL 508 shop. So, what it says here, OSHA requires conductors and equipment to be accepted only if approved. So the definition of approved is to be acceptable to who? The authority having jurisdiction. And that's per Article 100 in NEC. I've brought this up many times in a lot of the discussions we've had, people asking questions on the podcast. Now, the next thing that you have to look at, and this is important, OSHA 1910.303A, 1910.399, that's all definitions in OSHA. NEC 110.102, that's where you get into approval. And then pay attention to this, and 500.8A. Now, the reason we put that in there is because that's where you get into hazardous locations. Okay. Now,
I see. I kind of see what you're saying, Justin. That anything can connect the receptacle. So if it's in that location, then you need to make sure the receptacle is Class A protected. I 100% agree with that.
Okay. Then it says now have the same requirements considering. Listen to this: the acceptability of components, wiring methods, and equipment. Now, let me explain this. When you look at 500.8A, a lot of the equipment that you get in hazardous locations, a lot of stuff they do, especially when we're in the oil and gas field, chemical areas, things like that, you can't even purchase this equipment. A lot of it is custom-made equipment, and they do this by, well, actually, I'll tell you just from experience. Usually they'll get an approval and they'll have UL come out. But the guys at the manufacturing plant, they're basically telling UL what to do because UL doesn't have quite the experience that the people in the oil and gas industry have. And then what they do is they design that equipment. And then as authority having jurisdiction, they put everything together, show why they did this, and this, and this. And then they give it an approval. Okay.
True.
That equipment now has a third-party certification label on it to do exactly what they say that equipment will do.
Yep, I agree with that. Hey, I just want to give a big shout out to the Denver Nuggets. Good luck in the finals, NBA finals. They just tipped off, so we dropped a few people. Everyone's going watching the finals. I knew we were competing with ABC, so but just a big shout out to the Nuggets. Hope they play a good game tonight.
Now, this is something to pay attention to here. The authority having jurisdiction will usually require third-party certification for all equipment, just like they do for listing and labeling. Then it says, for third-party certification, a nationally recognized testing laboratory, or it could be a QTL, they used to call qualified testing laboratory, performs tests to verify if the equipment will do what it is designed to do, and what's this, and still be safe to who? The user. So once again, I'm pointing out here, once they do all this testing and everything, that equipment gets a field installed label or it's listed and labeled. It's designed to protect anybody that's going to be using that equipment. So
yeah, and I'm gonna have to kind of cut some people off at the pass when it comes to this, where just because it's not the user, it's some kid jumping the fence in South Chicago. it's still safe. You know what I mean? Like the overcurrent device still going to open. It's just that whole thing. I mean, yeah, it was a tragic death. Vontrell Pargo, rest in peace, 2007. Yeah, it was a tragic death. It was horrible, but you cannot continue to just say every single appliance has the hazard of a kid jumping your fence at 10 o'clock at night onto a unit that's miswired.
So let me give
to
you
me,
I'm going to give another example to prove this point. Why can I not take outside and just put a regular receptacle out there? Oh, I know, because it's not listed and labeled. It was tested that it's not safe enough to put out there. So in order to provide safety, we put what? A GFCI that's been listed and labeled and tested for that outside location.
And it's weatherproof and tamper resistant per code.
That's right. And that's what I'm saying. You can't just pick and choose where you want to use something. Once you have a listing and labeling, they tell you what that equipment, device, whatever it is you're using, it has been listed, labeled, and approved for that location. And the authority having jurisdiction is going to accept that. Now,
yes, sir.
The thing is here, they want that listing or labeling or that third-party certification, because the problem is, if they do not have that, guess who takes sole responsibility? The authority having jurisdiction. And they're not going to do that without a listing and labeling.
Yeah.
You see what I'm saying?
Yeah.
That's why all this matters. Now, I want to put something else here. We got an approval tip here I want you to pay attention to. OSHA demands third-party certification by an independent testing laboratory for any and all electrical equipment designed and installed in industrial locations. Custom-made equipment is acceptable where the equipment needed is not available to be purchased and is not listed and labeled by who? A nationally recognized testing laboratory such as UL, ETL, Goodhue, Strauss, any of those. The Canadian standard was CTL or whatever it is. But when you look at this right here, where we get into a lot of custom-made equipment is where? Industrial locations. Okay? Now, if I'm
sorry to interrupt. Thanks for joining us, Juan. Juan's got to take off. His dad's been in the hospital and stuff, but
sorry to hear that, Juan.
We appreciate you joining, and he's in our prayers for a speedy recovery. And, appreciate you joining, Juan. Have a good night, sir.
Brother. He'll be in our prayers, brother. Okay, now, as you look at this and you look at standards to review, we got it set up to sort of tie all this in. If I look at 90.7, what is that? That's examination of equipment for what? Safety.
Yes,
safety. 110.2 gets into the approval. Article 100 gets into the definition of approved, which is acceptable to the authority having jurisdiction. And 110.3 B and C deal with what? Listing and
label equipment.
Yeah. And when you look at the OSHA sections, they're going to tie in with what is there with the NEC. And that's why I put all this together so people could see exactly what OSHA is requiring out of this. And they're basically saying the same thing. Once that equipment has been listed and labeled, it has a third-party certification, whatever it is, that equipment is intended to be used in that manner, and it takes and provides what? Safety.
Yep.
So
thanks for smashing the like, Juan. We really appreciate you smashing the like, Juan, and everyone else in the chat. Smash the like. We love it. Love hearing your guys' feedback.
Sure. Now, this just finishes a little bit of this. The examination, installation, and use of equipment. And it tells you all electrical equipment at work must be rated to what? OSHA regulations and comply with the provisions of standards and installation instructions of what? Qualified testing laboratories that have been tested and certified. And these are some of your testing laboratories that do this testing. Okay.
Right.
Now, once it's been done, OSHA is telling you that it's been tested and the equipment has been certified to provide what? safety. So once again, I would argue, where does the National Electrical Code come in and override the listing and labeling of what's taking place with the listing and labeling of that equipment?
Yeah, so I would say that there is certain instances, like I would say that, like if you had, let's just say, a listed and labeled refrigerator, you're putting in a kitchen and the receptacle was within 6 foot of the sink. So that would require Class A protection because it's within that zone that requires Class A protection. Now, that's not a refrigerator receptacle. That's just a kitchen receptacle that's within 6 foot of a sink. So I don't want to muddy the waters with that, but I'm not saying that the National Electrical Code is overriding the listed labeled equipment. I'm just saying that whatever that refrigerator is plugging into has to be further than 6 foot from a sink. And that kind of muddies the water further with 2023 because now they're saying every receptacle in a kitchen has to have Class A protection on it. Well, now that kind of opens the door for this, what I'm talking about in 2026, to be like, if you have a listed and labeled piece of equipment and it is a compatibility issue with the Class A device, you can put on a standard thermal mag in 2026. That's what I'm going to say is going to happen. I'm guessing, but I'm just seeing the way that this is going because there's too much equipment that has compatibility issues with Class A devices.
Sure,
And
they're going to have problems with 210.8D, some of the new stuff they put in, and
yep.
they're about to get kickback on that, I think. And when that happens, what you're going to see is you're going to see a lot of manufacturers come in and say no GFCI protection, and the code is not going to override that. Period.
I 100% agree with that.
Okay. Now, when you get into the examination part, it tells you here. Now, I want everybody to listen to the very first sentence to what I put in here. The NEC, OSHA, and NFPA 70E do not include detailed requirements for wiring inside of electrical equipment. Period. Okay. Information pertaining to the internal wiring equipment is usually found in individual standards that contain special requirements for installing the equipment concerned. It is not the intent of the NEC and OSHA to take away the authority of inspectors to examine and approve equipment. Okay? Now, when you look at that, it says, however, the NEC, OSHA, and NFPA 70E indicate that the rules pertaining to the internal construction equipment are usually investigated and approved by who? A qualified testing laboratory.
That's right. Mostly UL, under a UL standard.
And then it also says the National Electrical Code does not make a flat rule to the effect that all electrical equipment shall have third-party certification of equipment by independent testing laboratories. Then you go through all the sections we went through earlier. But then if you look at OSHA, on the other hand, does require electric equipment to have third-party certification for safety of personnel. Listen to this one more time. For safety of personnel using such equipment per subpart S to 1910.303A. So they're telling you OSHA is the defining de facto on this, not the NEC. And they're telling you that that equipment is being designed, tested, and everything to provide what? Safety.
Yeah.
And for somebody on an NEC code-making panel come in and tell you that they override what the UL listing is totally false. OSHA will not ever say that. They specifically put it here. They give these certifications and listing and labelings because it does protect personnel from what? Safety.
And it doesn't protect personnel from safety. It protects personnel from electrical hazard. But what I'm saying is that the whole thing with OSHA, I'm just joking with you.
I say, yeah, safety of personnel. Like, what the hell is he talking about? Yeah, my mind's going so many ways right now.
It's all good. It's all good. But what I'm saying is that when you look at it, it doesn't matter if you're a kid jumping the fence or you're that person that's going to turn your AC on, or you're that HVAC contractor that's coming to look at the unit. That's all the same thing compared to OSHA. They want to pick and choose and get this like, well, this guy was coming to look at the unit and this guy was jumping the fence, innocent victim,
Mhm.
And the thing is, they're all the same when it is viewed from OSHA.
Mhm.
And it's when you're saying OSHA, it's Occupational Health and Standards Association. So technically, OSHA is not really creating a workplace environment for Bontrell Pergo while he's jumping the fence, and to me, that's overreach of the code making panel, and I think it's wrong. Andrew comes in. He says, I do disagree with deep freezers on GFCI. I've come across many service calls of people losing food.
Oh yeah.
Well, we just heard of a predominant code guy out there that lost $2,000 worth of hunting meat, and I think he even lost his freezer because it was full of like meat juice or whatever, and this is it too, Andrew. One elk hunt that cost $10K to go to Colorado and take a 700-pound elk. Yeah, dude. I mean, yeah, 10 grand that you lost. And, this is kind of a case with this code guy where he's on his little code adventures and there might not be any kids around his house that are going to be getting, welded to the frame of a freezer. And it might not be I think it has to be kind of a thing. If I had kids or something, I had like a whole bunch of kids running around, I think I'd be okay with losing, 10 grand in meat as long as I didn't lose one of my kids. I mean, but you have to weigh that whole thing. In my opinion, that's just my opinion. I'm not trying to say, anything that I know anything. I'm just trying to say that in my opinion, I would weigh that and I would say, in my opinion, anything plugged into a non-GFCI in my career has not killed anybody that I know of, but I've seen it. Like, a lot of my opinion comes from me going over to my friend's house. He says, yeah, my freezer's shocking me. And I go over there, what? Your freezer's shocking you? Like, well, only when I have bare feet, And I'm like, okay, so I'm like scared to touch this thing, And I'm going over there and it's got a little weird thing going on to it. It's kind of shocking you,
Mm-hmm.
And so I'm like, he goes, yeah, can you check it out? I was like, yeah. So I unplug it, I tear it apart, and there was just a little hair. And we were talking about this too, James, about the stranded wire.
Right.
There's a little piece of stranded wire, one of the ungrounded conductors touching that frame. And it was just enough that you'd feel a buzz off it,
Right.
And then he's, oh yeah, it gets worse when it gets wet. Well, yeah, that water, that condensation comes up, it grabs on that strand, starts actually energizing the frame more.
Sure it does.
And then come to find out, none of that whole frame was even grounded, So I started like, well, how's that voltage even getting into the frame, into that metal parts, Right. And I started researching it, and I went and I put it all back together, and it was working great after that. Nobody's getting shocked after that. Right. So, it is what it is,
And that's things that you fall into. The equipment is designed to do what it's supposed to do, but anything can happen to where somebody, it's sort of like you take some of these co-making panel members. What do? They play the what if game. Well, if we're going to play the what if game, guy, you got to protect everything that's out there in the world. I mean, you can't do that at all times. You got to depend on the listing and labeling. But as you look at the installation use here, Ocean's relationship to electrical equipment, it's clear here when you look at subpart S for the electrical in 1910. It says electrical equipment shall have third-party certification for essential safety equipment and components used to assemble electrical installations. For the safety of personnel utilizing such equipment, OSHA requires the following. And these are definitions I put together for this. This is all from OSHA.
Yeah, and I agree, Justin. Yeah, you can, like, that's the whole reason with OSHA. Like, OSHA can only take safety so far.
Yeah.
You
And
know?
if you look at it, OSHA, exactly by their name, Occupational Safety and Health Administration, they're focused on safety and your health. So if they're saying that you do these third party certifications, you got listing and labeling, the equipment's been tested, they're basically saying it provides safety. That's what they do. Okay. Now, as I look at utilization equipment, it tells you equipment that utilizes electrical energy for what? Electronic, electromechanical, chemical, heating, lighting, and similar purposes. Okay.
Yep.
Everybody, that's pretty much word for word what you're going to see in the NEC. Now, watch this. Approved, acceptable to the authority enforcing subpart S. The authority enforcing subpart S is the Assistant Secretary of Labor for the Occupational Safety and Health. The definition of acceptable indicates what is acceptable to the Assistant Secretary of Labor and therefore approved within the meaning of subpart S. So if they're looking at these different methods of doing their approval of equipment, in my opinion, at this point, even the Assistant Secretary of Labor accepts the listing and labeling or where I do third party certification. Okay. Now, the next thing you want to look at here is where you get into the definition of acceptable. Now, everybody watching this podcast, if you go look at the definition of acceptable in the NEC, it's going to say acceptable to the authority having jurisdiction, or really the definition of approved, but it'll say acceptable to authority having jurisdiction. Now, I want you to look here, look at all the stuff that they're going to reference here as far as acceptable is concerned by the Secretary of Labor. And they tell you what is considered approved within the meaning of subpart S of OSHA 1910. It says if it is accepted or certified, listed or labeled, or otherwise determined to be safe by a nationally recognized testing laboratory. All the things I've been talking about up to this point. So if I have a piece of equipment out there, it's outside, and they tell you no GFCI protection, guess what? It's been listed and labeled here in OSHA's eyes that that is a listed and labeled piece of equipment. Then it says in Prin 2, it says with respect to an installation or equipment of a kind that no national recognized testing laboratory accepts, certifies, lists, labels, or determines to be safe, if it is inspected or tested by another federal agency or by a state, municipal, or other local authority having responsibility for enforcing the occupational safety provisions of the National Electrical Code and found in compliance with the provision of the NEC or is applied in subpart S. Now, basically, we just looked at that a while ago. If you do not accept or look at listing and labeling or third party certification as authority having jurisdiction, you can accept this, but this is what you're going to look at doing at this point, and you're going to take full responsibility. Personally, I wouldn't do that. Okay, unless I was set up in order to test that equipment and know this. Now, then it says in Prin 3, with respect to custom made equipment or related installations that are designed, fabricated for, and intended for use by a particular company or customer, if it is determined to be safe for its intended use by the manufacturers on the basis of test data, which the employer keeps and makes available for inspection to the assistant secretary and his or her authorized representatives. This goes back to what I was saying a while ago. If I go out into the oil and gas field, chemical and stuff, they have the test data that shows equipment they've been using and how it operates in that hazardous area. So they probably have better test data than what UL or ETL, the Canadian Standard Association, Goodhue, Strauss, Factory Mutual, all of them, they probably have better test data. So that's what they're telling you here is you got a basis of test data that you may design that custom made equipment And that's why I was talking specifically about industrial equipment at that point.
Right. Well,
Okay.
Andrew came up with a haymaker here. Well, let's see if we can answer this one.
I'll tell you my thought on that. I would tell Frank, my brother, he's a contractor, and he's told customers that he's wired for, and they've lost their GFCI protection, or their I don't say lost their GFCI, but they lost meat and stuff that was from a freezer, and they called Frank out there thinking wanting to blame him, and he said, "No, we have this problem." And Frank has a little form that they fill out that they do not want it on GFCI protection because they're losing their meats and things like that. And he puts it on a regular receptacle, and they don't have any problem anymore. So,
Nice.
as an company, you want to put it on GFCI protection because the inspector's going to make you, but the homeowner gets all upset when they lose something. I told him, I said, have a form or something that they fill out that they realize the responsibility they're taking for that. So you're not held liable. Okay.
Yeah, that's a really good thing to do. I mean, so there's your answer, Andrew. Just get them to sign a form and get to go.
Yep. All right. Now, the next portion is you get into labeled and listed. And basically, it's just what is labeled. It's just a label, symbol, or some other identifying mark that goes on the equipment. And listed means that it has what? It's been published by a nationally recognized testing laboratory that makes periodic inspections of the production of such equipment. Okay, and then it states that such equipment. Listen to this. Meets the nationally recognized standards or has been tested and found safe for use in such a specified manner. Now, that's interesting because what we're saying at this point is that if I put an AC unit out there, guess what? It's been tested to say it's safe out in that environment.
Well, it better be 10 foot away from the pool. That's what I'm
saying. Then listen to this. This and everything I'm telling you, this is OSHA. Okay. What does OSHA say about accepted? It says an installation is accepted as has been inspected and found by a national testing laboratory to conform with what? Specified plans or to procedures of applicable codes.
Yeah.
Now that's something right there. So
let
me ask you this. If I have an AC unit out there, an ACU manufacturer say no GFCI protection on this. Guess what? They had a listing and labeling. It's been tested to say that equipment operates just fine. There's no hazard to personnel. The NEC does not have the right to come in and classify GFCI protection on that unit now.
I agree.
And that's what this is what accepted is, because they are saying it has been inspected and found by a nationally recognized testing laboratory to conform to what? Specified plans or to procedures of applicable codes. So that means they looked at the NEC and everything else out there and determined I don't need GFCI protection. So when you have code-making panel members come in and say, nah, you still have to put it on there. Well, tell OSHA that, because they're telling you it doesn't need to be.
I agree.
See what I'm saying?
Yeah, I really feel that's the target why they went with dwelling units.
Mm-hmm.
And the thing is that that even could be one of a myth that we come up with too coming up soon is if you're working on a residential dwelling unit, does OSHA apply?
Sure.
Does 70E apply? It's a workplace.
Let me ask you this. Let's say that you go outside and you have equipment out there in a hazardous location, and by listening to the golden boy Ryan, he says at the end of the wiring method is where your outlet is. So if I go out there in a hazardous location, you going to tell me I need GFCI protection there, even though it's custom made equipment and they determine it doesn't need it. That is not correct. I don't care. It is not correct.
So the hazard that would be generated by that equipment being shut down would be greater than be prevented by it being installed on a GFCI. That's my argument on that one.
Sure. Now, I want to put something. Earlier, I referenced 500.8A, where I was doing industrial equipment and I was giving chemical locations as an example. And, there's a reason Dad and I had gone out all these years, and we have a course that we specifically did for custom made equipment for these areas. And we'd go out and teach this. Well, when you look at the very last sentence to all of this, it says, custom made equipment should be designed and built by the provisions listed. Now, listen to this: NEC, UL 508, NFPA 79, and one of the C series published in ANSI. And it says, based on the type of equipment involved, the customer specifies to the manufacturer the function that its equipment shall perform. Now, if they come in and say no GFCI protection, but yet the custom made equipment, or even my listing and labelings, everything else that's done is based on the NEC and these UL standards and C series, whatever I'm going through, and they say no GFCI protection, but yet it was designed based on the National Electrical Code, where does these members come in have the right to automatically say, no, you need GFCI protection?
True.
I mean, I'm giving everybody what OSHA says here, and they're telling you it's designed based on the National Electrical Code, even, and they're saying no GFCI protection. So how can you say I need GFCI protection? But I regress. I'll go a little bit further. Now you look at where I get into custom made equipment, where you do a UL 508 and 508A. Now, the reason I bring this up, because this is sort of the same process that these manufacturers go through when they get listing and labeling for their equipment, okay?
Mhm.
And identification and all of that. Now, what it says here, UL 508 and 508 contains basic requirements for products covered by Underwriters Laboratories under its follow-up service for this category within the rules and regulations of the standard. These requirements are based on sound, listen to this, engineering principles, research, records of tests, field experience, and the appreciation of the problems of manufacture, installation, and use derived from consultation with and information obtained from who? The manufacturers, users, inspection authorities, and others having specialized experience. They are subject to revision as further experience investigation may show as necessary or desirable. Now, I want to stop right there because that's all I need to read, because they basically just told you when they do their testing and labeling, they look at everything: engineering principles, research, record of tests, field experience, appreciation of the problems of the manufacturers, installation, consultation if there's any problems from the manufacturers, users, inspection authorities, anybody that has specialized experience. So if they go out there, you've got all these people that have written these UL standards in order to take and do their listing and labeling or do a third party certification, and they tell you that equipment operates fine. And as we were talking about, an AC unit, been out there operating all these years, no problems or anything. And the only incident they have where people get killed is been because it was improperly wired, or people were working on it without applying their lockout tagout methods and safety procedures. And those are your deaths. How can you take and say that the equipment isn't operating and performing the function it's intended to?
Yep, I agree. Andrew has a question for you. And I think what he's going at on this is a clearance for like readily accessible.
You got to have readily accessible. And I've stated this many, many times. When you get in and you start looking at a disconnect, if the disconnect doesn't have any type of fuses, shunt trip, any of that in it, then you don't have to have accessibility, because by OSHA, you're supposed to go upstream and lock and tag that out anyway. And then there's rules, even in the 70E and OSHA, when you disconnect it before you work on it, we tell you to make sure all the blades have been disengaged. But when you start having one that's fusible in there, you got something, a device in there. Now all of a sudden you've got to have clearance around that. And
Yeah.
because that device, you could come in there, check your fuses, whatever's there, to see if I have a bad fuse or something. In other words, you can interact with that disconnect while it's what? Energized. And when you go
Yeah.
look at 110.26, it's going to specifically say, or 26A, when you're looking at it, says when you're working on equipment that likely requires what? Examination, maintenance, things like that, while it's what? Energized. Okay.
Yeah,
That's
and
the difference.
I would actually argue, Andrew, that that sounds like a piece of equipment that you could interact with, verify that it's de-energized, without having a proper clearance. Like, I don't see you happen to open that shunt trip up to verify power or anything. Like, if it's de-energized, you can go upstream and verify that it has power downstream, which you would be using your PPE upstream to verify that it has power downstream.
And that's what you get into. You take a lot of older disconnects that are out there that didn't have clearance, but they're fusible. I mean, what they do, they put rules in place. If you have to work on that while it's energized, and that's the key. If there's some, let's see, but if there was a fire, the equipment would shut down anyway. Yeah. But what I want to point out is there's a lot of facilities that didn't have those clearances a long time ago. And if they have to work on that while it's energized, they're required to put down blankets, mats, wear sleeves and things like that because they don't have the clearance. So they're doing a means of protection to protect themselves. And that's where you need to look at 70E and OSHA to apply that.
I would say, Andrew, that you would be disconnecting that upstream to work on the equipment personally, if it was in that situation.
Well, now that's why I was going to finish this up, because you take some companies and they verify everything's completely de-energized before they work on it. Therefore, they didn't need any clearances because they were never going to work on it energized anyway. So it depends on how your safety standards set up.
Yeah, Andrew, a good rule of thumb that I've learned, and James probably got me on this a bunch of times, is that if you don't need the working clearance if it's not likely to be worked on energized. And we ran into this with a gear section that was 4160, and the 70E teacher was like, "Are you going to take those screws off unless you're suited up?" I was like, "No." Because basically you're within the restricted space to take the screws off. So you have to suit up. You have to dress for that condition. So it's basically the same thing with working clearance, Yeah, so it would be 110.26A, Andrew, and it basically says if its equipment is likely to be worked on while energized. So if that shunt trip is likely to be worked on while energized and it doesn't have working clearance, then
you need it.
It would.
And that's what I was saying. It depends how you look at it. Now, if you're not going to work on it energized at any given time, then you want to take and make sure that's in your specs, and therefore you lock and tag everything out, verify it's de-energized, and then you're good to go.
Yeah, there could be times, Andrew, we ran into this before, where the customer's like, "I want this for convenience or something," and you're like, "Okay, well, you need 3 foot for convenience," and then they're like, "Okay, we're not doing that."
And that's what I was saying. It depends what you're doing and how it's set up. But
it's 110.26A, Andrew. I'm not exactly sure the whole exact part of where you would go, but 110.26A is where it starts, and you would just follow it through.
But I will say this: if you have somebody that's coming in behind you, and it's not a facility that already has set up safety procedures and everything, I'd say you need the clearance, because you don't know what somebody else is going to come in behind you and do.
Yeah, you don't want a guy to come in and try to test it.
Somebody doesn't know what he's doing.
And a lot of times what I've seen, Andrew, too, in those kitchens is those ovens are only allowed to roll out like 12 to 18 inches.
Mhm.
They have like a chain on them, or they have like a cable tie, and they only roll out so far for you to work on them.
Right.
So I would say that's not an ideal location for electrical equipment.
Sure. Now, I want to point one other thing else. When you're applying your UL 508, when they look at this and they judge and evaluate these devices and accessories and everything, it's based on 5 main categories. They look at the construction of the equipment, the performance, the rating, the marking, and the instruction and use of that equipment. And these are for devices that are rated 1500 volts or less. Okay. So
Gotcha.
they go through everything to make sure. So, it was sort of like what I was saying the other day. They took an AC unit and they first they told me it was the outlet was at the load side of the disconnect. I proved that wrong. Then they said it was inside at the AC equipment. I said, is that rated for a wet location?
Mm-hmm.
And they said, what the hell's that got to do with it? I said, well, you're
Yeah.
trying to take an NEC requirement and place it inside that equipment. That you don't have any NEC rules that I'm aware of, especially when you look at 90.7 that apply to the inside of that equipment. Okay.
So yeah, and what you come into is when you remove the receptacle, you remove the hazard? And the answer per code is yes. You do. You do remove the hazard by removing the receptacle.
That's right.
But then they say, okay, well, do you remove the hazard if you remove the outlet? And they're saying that the outlet just exists everywhere now. Now everything has an outlet, And
Sure.
to me, it's just like one upping on what was already fine. There was never any problem with that. So one thing I wanted to answer for Andrew, I agree with you, sir. There is so many different inspectors that interpret things different ways, and what I would say to the inspector is it likely to be worked on while energized? If the answer is yes, then yes, it needs clearance. If the answer is no, we can isolate it upstream and work on it in electrically safe work condition, then no, the working clearance is not required.
Well, I'll just tell you, it's been my experience. A lot of the new inspectors, they're a combination, and some of them were plumbing inspectors learning electrical, and they don't really know. And what I would suggest to you is tell them to come watch this podcast. They'll learn a lot about the OSHA requirements and looking at equipment and its listing and labeling and how that equipment's to be used and based on the type of installation that's going in. That's why we do this, is to tie in and show you other standards. I haven't seen a lot of other podcasts that I haven't even seen one that actually goes in and shows you UL requirements and tying it in with UL, the National Electrical Code, your ANSI C series. There's just so many different things. NFPA 79. This is what you're looking at when you get into this. So when you look at this and you look at the construction of that equipment, it's constructed in such a manner. It could be take the AC unit. You got that fan going. Do you think it's constructed in such a manner to take care of the vibration that's in that equipment? Sure. And then the performance, they have it perform for whatever the BTUs or whatever they're going to be pushing through, what it needs in order to cool that house. And then you have a rating and marking, and then it has an instruction and use of how that equipment is to operate.
Yeah, and just a FYI, Andrew, I really appreciate you joining. You have some really great points tonight. Just because it's a disconnect with the handle that you have to shut off does not mean you have to have 3-foot working clearance. So that's one we should do. I think we already did that one, didn't we? The 3-foot working clearance for disconnect.
Yeah,
I think I had one.
I did that a long time ago.
That had the AC unit with the disconnect right above it.
Sure.
And the whole thing was, Andrew, that disconnect was not likely to be worked on energized, because you could go to that breaker, kill it, verify it's de-energized, and then work on it safely while you're sitting on top of the AC unit.
Sure.
You don't require that 3-foot working clearance.
And I'm not going to spend a lot of time on this authority having jurisdiction, but they're just the ones responsible for approving equipment installation and procedures. And basically, they're just telling you what the authority having jurisdiction can do, which I've already explained all of this, and their responsibilities as far as interpreting the specific rules and regulations as it pertains not only the National Electrical Code, but also OSHA, UL, other NFPA standards, and also ANSI standards. Okay.
Yeah, and this brings up my whole point that I installed an EBSE charger at a personal friend of mine's house, and I asked if they wanted it on GFCI, and they were like, no. They were like, it says right here it already has GFCI in it, and the only thing what I had to do, I had to hardwire it, and then I went to the AHJ, to the inspector, and I said, here's the listed and labeled manufacturer instructions that say it just needs to be hardwired to a 50 amp breaker and we're good to go, right? And he's like, yep, looks good. Integral GFCI, integral personnel protection. I don't want to say GFCI protection because it's called personnel protection. That's going to be kind of a gray area, I think, coming up in 2026. But personnel protection is not the same as Class A protection. Class A protection is for personnel, I believe, for human interaction. And then
that's what I've always said. It's where human interaction takes place.
And then you have the GFPE that is compatible for the equipment. Well, the reason we bring up EBSE is because Andrew has you Dangle, aka HJ. So, James. But so the whole thing is that the reason we had this argument is because Code Making Panel 2 members have stated that the EBSE equipment does not provide Class A protection for personnel upstream of the EBSE. And the problem that we have is that, okay, so here's the charging cord that plugs into your vehicle, and that has integral personnel protection, but it's at a 20 milliamp, so it's technically EBSE. It's not technically up to par with what CMP2 says, but this perceived hazard of all these people have never been electrocuted from EBSE, are based on something from 2007 when EBSE didn't even exist. So I think that's why we're trying to kind of fight back on it and kind of get the real what's going on here,
Well, let me just say this. Say it's rated at 20 milliamps. Basically, they're saying it's going to detect any equipment malfunctions that take place before that human interaction ever takes place. Therefore, 100%. It has been designed and tested to protect people from what? Hazards. It provides safety. And therefore, since their equipment is designed that way, which is UL listed and labeled, by the way, and they say no GFCI protection upstream, there's a reason for that. They're protecting their equipment and personnel that are going to interact with that equipment. And for Code Making Panel 2 or members on there that come on the thing and say, oh, no, you still got to put GFCI protection. They don't know what they're talking about. And I'll tell them, you cannot take and say that the listing and labeling is not compatible at that point. That's basically what they're telling you. That we don't care what the listing and labeling is. You're going to put GFCI protection, but they don't have the right to do that.
Well, I actually have the recording of this before. One of the predominant code people actually said you cannot install it in that location. You know what I mean?
He didn't know what he's talking about.
Yeah, and I don't want to say his name, but it was funny because like, really, you can't install it there. Okay. I mean, that's like, how you gonna tell your customer that? Oh, sorry, you can't install it there because it's not compatible with the Class A device.
What did they say? If there's not an outlet, it won't operate. Really?
Oh yeah,
I'll say there's no outlet. Hook it up, and I bet it works.
yeah, that works. Works with no outlet.
All right, you ready for your tool, brother? I hope everybody
Yeah,
enjoyed that because that was a lot of
yeah.
information in a
No,
short time.
Andrew's been hanging with us. Appreciate you, Andrew. And Andrew's asking if there should be a disconnect upstream of the shunt trip breaker behind the oven. I would imagine that it comes off a breaker, and I would actually say the breaker would be sufficient disconnect upstream for a shunt trip. And I'm not sure the exact situation, Andrew. So I could be completely off base. I could be 100%
Nope,
wrong, but
that's a disconnecting means. If you go look at the definition of disconnecting means, it'll say a device or group of devices, and you go look at a device. Guess what's listed there? An overcurrent device.
so he's talking about on the EV charger. So what we're saying is you have a breaker, 50 amp breaker. Let's say it's a 50 amp 2-pole, and then it goes to a bell box, and then you hardwire it to the EVSE charger, and then that goes to your vehicle. That's 100% code compliant. The breakers
Sure,
within 50 foot or line of sight of your equipment, and you know what I mean? No disconnects needed. Now, if you go outside that 50 foot or line of sight, then you would need a disconnect. But if you hardwire the disconnect, then no GFCI is required either.
correct. And I think that new one, I think it is. I think within sight they moved it out of definitions. I think it's now what 110.29. I think it is.
Yeah. Yep. Yeah, you're right. Yeah, they did that.